In our previous video, we talked about strong electrolytes, and that strong electrolytes, alkali metals, ammoniums, and nitrates, and these 7 strong acids, when you put them into water, they completely dissociate. And by completely dissociate, I mean you put NaCl into water. Notice the arrow here, because that arrow is going to become important today. Notice it's only an arrow to the right, and it forms Na plus and Cl minus. That is a strong electrolyte. Okay, so anything with an alkali metal, ammonium, or a nitrate is completely soluble. A strong electrolyte conducts electricity very well, and these 7 strong acids. Okay, however, sometimes things aren't strong electrolytes, but they're also what we're going to talk about in a second, non-electrolytes, okay? There are things that are called weak electrolytes, okay? So if it does conduct electricity a little bit, then we say it is a weak electrolyte. And the times that you will see a weak electrolyte on the AP test is anytime you are dealing with an acid that is not one of those 7. The 7 strong acids are always strong electrolytes, and any other acid is therefore not a strong acid and considered to be a weak acid. Okay? So, strong acids are strong electrolytes, weak acids are weak electrolytes. Well, how do we know if it's weak? If it's not a strong acid, one of those 7, then it is a weak acid. Okay? That's all you need to know. Okay, now what about bases? We haven't talked about bases much yet. We haven't even really talked about strong bases versus weak bases. Well, a strong base is something like NaOH. Notice it has an alkali metal in it. We already talked about that. Okay, so a base, an acid, and we're going to get into acids and bases in much more detail later on, but an acid is something that when you put it into water, it creates hydrogen, or this is called the hydronium ion. It creates hydrogen ions. Okay, this and this are the same thing. We'll get that into more detail later on. Okay, so a base is something that when you put it into water, it creates hydroxide ions. Okay, and that's a very basic understanding, but that's all you need to know for right now. An acid is something that creates hydrogen ions. A base is something that creates hydroxide ions. So the strong bases are bases that when you put them into water, completely dissociate and break into a metal ion and a hydroxide ion. Okay, whereas a weak base is something that, again, like a weak acid, does not completely dissociate in water. So a strong base, let's make sure we're very clear on this. So the strong acids are, again, those 7 we mentioned above. Okay, whereas the strong bases are, again, any alkali metal, right? Plus hydroxide. Okay, so sodium hydroxide, lithium hydroxide, potassium hydroxide, rubidium hydroxide, anything hydroxide is a strong base. And then also, because there's more detail that we'll talk about later. Okay, but these are the heavy alkaline earth metals. Notice right next to the alkali metals are the alkaline earth metals. Okay, and calcium, strontium, and barium. So CaOH2 is also a strong base. So strontium hydroxide, so is barium hydroxide. So if they mention a base and it has one of the alkali metals or calcium, strontium, or barium in it, it's strong. If it calls it a base and doesn't say if it's strong or weak, and it's not one of these, just like here, if it's not one of the 7 strong acids, it's a weak acid, then it's a weak base. Okay, probably more information than you needed to know for right now, but that's good information to know in terms of what are the strong acids, and therefore, because if you know the strong ones, and same with strong bases, then you know all of the weak ones as well. Now, if you have a weak electrolyte, how is it different? It's right here, okay? Notice that arrow, that's referred to as an equilibrium arrow, which means that as the products start to form, those products start to react with themselves to cause the reaction to go backwards, okay? And what happens is you create what's called an equilibrium system. Okay, and that's what that arrow is. That's an equilibrium arrow that indicates that when you're at equilibrium, the reaction is happening at the same rate, which means the forward reaction and the backwards reaction are both going forwards and backwards at the exact same speed. Okay? In fact, in the cases of weak acids and bases, the predominant species present solution is typically this one. So in a weak acid, equilibrium does not mean you have the exact same amount of reactants and products. It just means that their rates are going at the same speed. The forward and the reverse reaction are going at the same speed. And like I said, usually in a weak acid or a weak base solution, what you have mostly in that solution is that undissociated, the molecular version of that acid. Okay, so in a weak base, notice what happens with a weak base. And again, they would not expect you to know this is a weak base. They would tell you. Okay, they would say CH3NH2, comma, a weak base, blah, 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 blah. And you go, oh, if it's a weak base, that means when you put it into water, what does it do? The hydrogen comes off of the water and now forms with this, and look at what you form. You create hydroxide. But again, it's not fully going this way. It's creating an equilibrium system where now it's also going to go back this way. Okay? So, again, lots of definitions. Here's another definition about acids and bases. Notice that when something acts as an acid, it donates a hydrogen. Here, the water is acting as an acid because it donates the hydrogen to that CH3NH2. Okay, and this is the base because what does it do? It accepts the hydrogen. So that's another way to look at acids and bases. Again, we're going to get into much more detail with that later on. Okay, so example 1, weak electrolytes are only partially dissociated, which means they sort of break apart, but not very much. Again, you have mostly this, and you have very, very little of this in a weak acid solution. Okay, so this is a reaction. This is when you put acetic acid, sometimes they call it ethanoic, but that's acetate, the C2H3O2 minus. That's in the acid form, so that's acetic acid. You put it into water, it creates an equilibrium system where the hydrogen ions and the acetate ions are broken apart. Again, you've got the double arrow, you're in a state of equilibrium, and that is a weak acid situation. Okay, and then with a non-electrolyte, it means what happens when you put it into water? Nothing. Okay, remember, it's the ions that cause electricity to flow. If something is a non-electrolyte, then it does not conduct electricity at all. Okay, well, what are non-electrolytes? Well, certainly insoluble ionic compounds. Okay, if you put an ionic compound that's not soluble into water, what does it do? Nothing. It just sits there. You put a rock into water, what does the rock do? It sinks to the bottom. It just sits there. Okay, so if it's an ionic compound that is not one of those solubility rules that we've learned, then we have to assume that it is insoluble. Again, unless they tell you something different. There are other soluble ionic compounds, and so if they tell you that on the AP test, then you have to be aware of that. Okay, so if it's insoluble, and also if they give you, obviously, a molecular compound, okay, CO2, okay, SF6, anything that's all nonmetals are also non-electrolytes. So they're not ionized, there are no ions present, so when you put a solution of ethanol into water, what do you get? You get nothing. You get a mixture of ethanol and water, and they just kind of mix together, and of course the C2H5OH doesn't break apart at all. Okay, so let's clarify here. That's it for electrolytes. So let's just clarify here. We want to talk about, I'm going to make a new, maybe, add a page, there we go. So we're going to talk, let's just identify all of these. So strong electrolytes are the soluble ionic compounds, which again are alkali metals, ammonium compounds, and nitrate compounds. Okay? And the 7 strong acids. And again, which ones are those? Again, I've got them in my head. I've got them in a group of 3. So I've got HCl, HBr, and HI. That's one group. And then I've got the chlorine groups, HClO4, HClO3. And then I've got the last group, just kind of throw the last 2 together, HNO3 and H2SO4. Those are the strong electrolytes, okay? The weak electrolytes are weak acids. How do you know if it's weak? Again, anything that's not one of those 7 strong acids, or a weak base. And again, how do you identify an acid or a base? They're going to tell you on the AP test. They're going to say that HX, comma, a weak acid, blah, 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 blah. Okay? But if they just give you the name of an acid, let's say they say propanoic acid, which is a real acid. Okay? Is propanoic acid a weak acid or a strong acid? Oh, I don't know if it's weak. Yes, you do, because it's not a strong acid. So if it's not a strong acid, then absolutely it's weak. Okay? And then the non-electrolytes are the insoluble ionic compounds. Okay, so anything that's ionic that doesn't have an alkali metal, ammonium, or a nitrate. And molecular compounds. Okay, so molecules, things that are made of, again, non-metal compounds. Okay, so, and why are those important? Because again, strong electrolytes, again, notice the arrow, completely to the right. Weak electrolytes create an equilibrium system, and non-electrolytes don't create any type of dissociation at all. So strong electrolytes completely dissociate, weak electrolytes partially, so fully dissociate, okay, partially dissociate, and don't dissociate at all.